alaikum wa rahmatullahi wa barakatuh. Dear my student, today we are going to discuss one of the important chapter in finance. It is called capital budgeting decision. In this chapter we are going to discuss one of the main decision related to financial management, which is capital budgeting decision. In this chapter we are mainly concerned with determining what is the long-term investment should the firm engage in. In this chapter we are going to achieve the following learning objectives. Number one, understand the key elements of the capital budgeting process. Number two, calculate, interpret different techniques related to capital budgeting process, such as the payback period. Second approach, the net present value. The third approach, economic value added. Fourth approach, internal rate of return and profitability index. Also, we are aiming to discuss the situation where NPV and internal rate of return will be in conflict, because sometimes you could have conflicting ranks when you are using NPV and internal rate of return. First of all, before we are going to discuss how we could use each technique, you must have the following concept, which is capital budgeting. What is the capital budgeting? This is the process of evaluating and selecting long-term investment that are consistent with the firm goal of maximizing ownership. This process, when you are going to support such a type of process, there is always certain type of capital expenditures attached to such a type of process. This type of expenditure, it is called capital expenditures. What is a capital expenditure? It is an outlay of funds by a firm that is expected to produce benefits over a period of time greater than 1 year. The main difference between this type of expenditure and the other type of expenditure, such as operating expenditure, it's regarding the maturity of this expenditure. If this expenditure is over a period of time greater than 1 year, it will be considered as capital expenditure. However, if this expenditure is over a period of time less than 1 year, in this case we could define it as operating expenditure. When we are going to support such a type of process, we are moving through the following steps. This steps is called capital budgeting process. Capital budgeting process consists of 5 steps. Step number 1, proposal generation. If you have a certain type of a new investment opportunity, so you must prepare a proposal for such a type of investment. Then the second step of capital budgeting process is to review and analyze each one of those proposals to assess the merits of investment proposals. Step number 3 is decision making, where the firm delegate capital expenditure decision making on the basis of dollar limits. Yani whether we have enough cash that enable us to accept and implement this proposal or not. Fourth step is the implementation step. And in this implementation steps, we are having the final approval, expenditures are made, and we implement this project. To assess whether this project is successful or not, the fifth step is the follow-up steps. Follow-up steps means we are going to monitor our actual costs, comparing it with our expected benefits to determine whether this project was a profitable one or not, and if not, we must search for the reason, and action may be required if the actual outcomes differ from projected ones. Those are the 5 steps of capital budgeting process. Also, before we start with explaining techniques, also you must aware of the following. Concepts. In general, we have 2 types of projects. We have independent projects, and we have mutually exclusive projects. What is the main difference between each one of them? Independent projects refer to projects whose cash flows are unrelated to one another. Yani those 2 projects are independent. This means that the acceptance of one doesn't eliminate the others from further consideration. If you have project A and B, if both of them are independent, which means that the acceptance of A doesn't eliminate the acceptance of B. In this case, we refer to those projects as independent project. However, we have certain type of project can be considered as mutually exclusive project. What are the mutually exclusive projects? Those are the projects that compete with one another, which is mean that the acceptance of one project will eliminate from a further consideration or other project that serve a similar function. This means that if we have 2 projects, A and B, if the selection of A will eliminate the selection of B because both of them are serving a similar function, in this case we could describe those projects as mutually exclusive project. Also, when you are taking capital budgeting decision, you could face with 2 conditions. The first one, that you have unlimited funds, or you are facing what we call capital rationing. What is the main difference between them? Unlimited funds, it's referred to the financial situation in which a firm is able to accept all independent projects that provide an acceptable return. And if we have 2 or 3 or 4 projects, all of them are achieving acceptable return, at the same time as a firm I'll have enough cash that enable me to accept all of those projects. But in this case we are facing what we call unlimited funds. However, in some situation you are facing what we call capital rationing condition. Capital rationing condition, it's a firm financial situation in which the firm, they have only a fixed number of dollars available for capital expenditures, and I will not in a position finance from the finance concept that enable me to accept all of the available project. In this case you are facing what we call capital rationing. And for example, if you are facing project A and B, however you don't have enough fund that enable you to accept all of the project, but in this case you must choose the most profitable project, because you are in capital rationing situation. Also in capital budgeting decision, actually we have two approaches. The first one, it's called accept reject project approach, or what we call a ranking approach. What is the basic difference between them? Accept reject a project, it means that you have a specific criteria, and based on this criteria you are going to evaluate your project based on this criteria. If this project is meeting the minimum acceptance criteria, you are going to accept the project. Otherwise, you are going to reject it. But in the accept reject approach, you have as a firm minimum acceptance criteria, and based on this minimum acceptance criteria you are going to assess your actual performance based on this criteria. If it meets this criteria, you are going to accept the project. Otherwise, you are going to reject this project. Another approach of comparing of different projects is to use what we call a ranking approach. What is the ranking approach? It is the ranking of capital expenditure project on the basis of some predetermined measure, such as a rate of return. You are going to make a rank based on some predetermined measures. But by the end of the section, you must understand what is the meaning of capital budgeting decision. Also, you must understand different concepts related to capital budgeting decision, such as acceptance reject approach, a ranking approach. You must understand the different types of project, whether those projects are independent project or whether those projects are mutually exclusive project. Let us take an example, and through this example we are going to use different capital budgeting techniques to assess each one of those projects. Here, this is a Bennett company. This is a medium-sized metal fabricator that is currently contemplating two projects. And there are two projects facing this firm. Project A requires an initial investment of $42,000. This is our initial cost. For project B, our initial investment is $45,000, and then you have the relevant operating cash flow for the two projects as existed in the coming table. As existed in the coming tables. As you see here, this is our two projects, Project A and Project B. The initial investment of Project A is 42,000. For Project B is 45,000. And then we have operating cash inflows over 5 years for each project. For instance, for Project A, our operating cash inflows are constant in an amount of 14,000 over 5 years. But in the case of Project B, our operating cash flow are not constant. For example, by the end of the first year, you have 28,000. By the end of the second year, you have 12,000. By the end of the third year, you have 10,000. By the end of the fourth year, you have 10,000. By the end of the fifth year, you have 10,000. First of all, when you have such a type of data, you must try to figure them out using our time line. In this timeline, as you see, in Project A, at time 0, we have cash outflow, which is the initial cost of 42,000, and then from by the end of the year 1 to the end of the year 5, we are going to have constant cash inflows in an amount of 14,000. The same situation of Project B, we are also going to figure it out using the timeline. As you see, at time 0, our cash outflow is 45,000, and then we have cash inflows by the end of each year over the 5 years as illustrated in this figure. Then after you are figuring the cash flow of each project, you must decide how we are going to compare between those two projects. Actually, in capital budgeting techniques, we have many techniques that could be used for this purpose. The first one, which is the most traditional one, is to use what we call the payback period or a payback method. Payback method, you are aiming to determine the amount of time required for a firm to recover its initial investment in your project. But in a very short way, the payback method is mainly concerned with how long a period of time is required to cover our initial cost or our initial investment. After we determine this period of time, which is the actual or computed payback period, we are going to use the following decision criteria. If the length of the maximum acceptable payback period is determined by management, and we are going to compare the actual or the computed payback period with the maximum acceptable payback period, which is determined by management. If the payback period is less than the maximum acceptable payback period, in this case we are going to accept the project. If the payback period is greater than the maximum acceptable payback period, in this case we reject our project, and this is very important in using payback period. Uh, Let us see how could we do it. For example, in project A, our initial cost is 42,000, and actually we are going to receive a constant cash inflow in an amount of 14,000. So this means that if we are going to have 42,000 divided it by our constant annual cash inflow 14,000, this means that exactly after 3 years we will be able to cover our initial cost. But this means that the payback period for project A is 3 years. But this is not the case in project B. Why? Because in project B we are going to have mixed stream of cash flows. For example, by the end of the first year we are going to receive 28,000 out of 45,000. By the end of the second year we are going to have additional 12,000. This means that by the end of the second year we are going to receive the sum of 28,000 plus 12,000. So this means that we already had or achieved 42,000 out of 45,000. So this means that the remaining part, which is 5,000, will become from the year 3. To determine exactly this period of time, so we are taking the difference, which is 5,000, and we are going to divide it by the cash flow of the third year. Since the cash inflow of the third year is 10,000, so we are going to divide the difference, which is 5,000, divided by the cash inflows of 10,000 in the third year, and this means half. But this means that the payback period for project B, it is 2.5 years. In this case, you must try to answer whether this is acceptable or not. This it will be based on the maximum accepted criteria set by the firm. For example, if your accepted criteria by the firm, for example, is 3 years, so this means that both of two projects will be accepted. But imagine that the accepted criteria by your firm is just 2 years. This means that both of projects will be rejected. Imagine that the expected criteria for this project is, for example, 2.8 years. This means that project A will be accepted because it is just 2.5. However, project B will be accepted because it is 2.5. However, project A will be rejected because it is 3 years, which is greater than the accepted criteria determined by your firm, and so on. As you see, this approach is very simple, and directly you could determine the payback period directly without any problem. Another example here, imagine this is our case, 0, 1, 2, 3, 4, 5. This is a timeline. At time 0, we have initial cost of 40, but at every year, at the end of the first year, we have 10. At the end of the second year, we have 12. At the end of the third year, we have 15. At the end of the fourth year, we have 10. At the end of the fifth year, we have 7. So this means that by the end of year 3, we are taking the sum 10 plus 12 plus 15. So this is about 37 37,000. So this means that our payback period will be between the year 3 and 4. But then it will be 3 plus something. So we take the difference between 40 and 37. This is the 3,000, and we divide it by the coming cash flow of the year 4, which is 10, and this will be your payback period in this case, which is 3 years plus 3,000 divided by 10,000. This will equal to 3.3. This is your payback period for this project. To determine whether this is acceptable or not, you must compare it with the acceptance criteria of your firm. For instance, if the acceptance criteria of your firm is just 3 years, but in this example, this project should be rejected. Why it should be rejected? Because it actually payback period is 3.3 years. However, the accepted criteria is 3 years, but in this case, we should reject it. Here, this is exactly what we did. We used the cumulative inflow, and we determined our payback period. And as I told you, whether this project should be accepted or not, or I told you that it will be based on a comparison between the actual and the maximum payback period. For example, the maximum payback period in this project is 3.5. Since our computed it is just 3.3, so this means that we must accept our project. If you give a look for this approach, you will find that this approach is very simple, and this is why we are aiming to use this project to assess a large firm and also to assess small firms. It's very simple because you just take the cumulative sum and then you determine whether it's acceptable or not based on the comparison with the criteria given by your firm. However, one of a drawback of this technique, it doesn't consider the time value of money. It doesn't consider time value of money. Why? Because as you see, we just take a sum and taking the cumulative of cash flows, and we assume that the cash flow occurred at the first year. It is equal to the cash flow occurred at time 2. It is the same as the cash flow occurred at time 3. And this is not true, because we explained before that time has a negative impact on the value of your money under the concept of time value of money. And one of the drawback of this technique didn't consider the impact of time on the value of your money. Therefore, if you would like to summarize the basic strengths and the basic weaknesses of this approach, we could say that the strengths of the payback period: number one, it's easy to use and understand. Number two, can be used as a measure of liquidity. Also, it is easier to forecast short term rather than long term flow. If you could use it to forecast short term flow, it's better than to use it for forecasting long term flow. But the major weaknesses of payback period: number one, it doesn't account for TVM, time value of money. It didn't consider the impact of time on the value of your money. And this is one of the biggest disadvantage of this technique. One of the greatest weakness of this technique, it doesn't consider the impact of time on the value of your money. Also, this technique doesn't consider cash flow beyond the payback period, because it is just calculate after how many years we will be able to cover our initial investment. Maybe in some project the cash flow is coming a little bit delayed. Yani sometimes in some project they are achieving a huge amount of cash inflows, but this it occurs a little bit late than to occurred early. But in this case, if you are depending on payback period, you are going to support the wrong decision. Also, this technique is based on a comparison between actual payback period and specific criteria set by the management. So this cutoff period in most of cases is subjective, and it's not accurate enough. Here, just give a look for this. Those two projects, Project Gold and the Project Saver. If you give a look based on the payback period, you will find that the payback period for Gold is 3 years, and Project Saver is also 3 years. If you are just based your decision on payback period method, you are going to conclude that both of them are the same, but actually it is not. According to finance concept, Project Saver is more better than Project Gold, because the majority of its cash inflows occurs at the earliest stage. Yani most of its cash inflows, which is 40,000, it occurred at the end of the first year, which is a little bit earlier than the Project Gold. But if you are going to depend on just payback period, you are going to assume that both of them are the same, and this totally incorrect. The same situation here also in this project, Project X and Project Y. If you give a look for a payback period, you will find that in Project X, payback period is 2 years. However, the payback period for Project Y is 3 years. In this case, if you just depend on the payback period, maybe you could say that Project X is better than Project Y. And this actually is not true. This actually is not true. Why? Because the majority of the cash flow of Project Y, it's occurred later on. It's occurred later after the 3rd year. The majority of its cash flow, it occurred after the year 3. However, in Project X, there is a small cash inflows occurs after 2 years. But this means that the payback period, it's not accurate in a comparison between two projects due to these weaknesses. Another technique which is very necessary for your understanding how could we compare between two projects. This technique, it's called net present value. What is the net present value? Net present value is a sophisticated capital budgeting technique, found by subtracting project initial investment from the PV of its cash inflow discounted at a rate equal to the firm cost of capital. And mathematically, we could say net present value, this equal PV of cash inflows minus its initial investment. As you see, NBV is equal to a discounted of cash flow occurred at a specific discount rate equal its capital power to T minus our initial cost. After we determine the NBV in this way, we are going to compare it according to a specific decision criteria. If the NBV is greater than 0, in this case, we are going to accept the project. If the NBV is less than 0, we are going to reject the project. In some situation, you could find that NBV equals 0. If NBV is equals 0, this is a neutral decision, and in such a type of decision, you will need to have additional factors to consider to support your acceptance or rejection of a specific project. Give a look for our exercise of Bennett Company. As you see, the calculation of NBV for Bennett Company. First, we are going to determine the NBV for project A and NBV for project B. As you see here in project A, to determine the NBV, this is equal to a BV of cash inflows discounted by a specific discount rate minus the BV of cash outflows. This means that the 14,000 every year will be discounted at a specific discount rate to determine the BV of cash inflows minus a BV of cash outflows. This will give you what we call the net NBV, which is 11,071. The same situation in project B. To determine its NBV, this is equal to the BV of cash inflows minus a BV of cash outflows. As you see in project B, we have 5 cash flow, 28,000, 12,000, 10,000, 10,000, 10,000. So each one of them will be discounted at a specific constant discount rate, and then we are taking the aggregate sum of those discounted cash flow to determine what is the BV of cash inflows. Then we execute our initial cost. Our NBV for project B will be 10,924. As you see, according to our criteria, we said that if NBV is more than 0, in this case, we should accept the project. For example, in the NBV for project A, it is 11,071. It's more than 0, we accept the project. The same situation, NBV for project B is more than 0, also we accept the project. But I would like to attract your attention for the following. What is this? As you see in NBV and for project A and B, you must ask yourself what type of those two projects. Whether those two projects are independent projects or whether those projects are mutually exclusive projects, because the decision will totally differ. Also, you must determine whether you have unlimited fund or you having rationing capital rationing, because this also will affect on your decision. Another third approach that could be used, we have what we call profitability index. Profitability index, we refer to it by a BI. It's very simple. It's equal to the present value of cash inflows divided by the initial cash outflows. As you see, a BI, profitability index, this is equal to a BV of cash inflows divided by a BV of cash outflows. The result in this case, we are going to compare it with specific criteria. If a BI is more than 1, in this case, BI of this project will be accepted. But if a BI is less than 1, in this case, this project will be rejected. Here, give a look in our Bennett example. We determine profitability index of project A, which is equal to BV of cash inflows divided by a BV of cash outflows. This is equal to 1.26. And then we have a BI of a B. This is equal to BV of cash inflows divided by BV of cash outflows. This will equal 1.24. As you see, both of them is greater than 1. In this case, we could accept both project A and B. The fourth technique that could be used in supporting capital budgeting decision is to calculate what we call economic value added, EVA. EVA, it's similar to a NBV technique where we are starting by calculating the project net cash flows. EVA is similar to NBV where both of them is started by calculating a project net cash flows. However, in the EVA approach, we subtract from those cash flows the charge that is designed to capture the return that the firms and visitor demand on these projects. EVA, it's very important where we determine whether the projects earn a pure economic profit or not. And this is very important in a comparison between different projects. In EVA, economic value added, we are interested to determine whether a project earns a pure economic profits. And this pure economic profit will be based on it. We determine whether it is above the normal competitive rate of return in a line business. Let us see how could we calculate EVA. Imagine that we have a project. This project, its initial costs is 1 million, and this project it will generate net cash inflows in each year in a shape of perpetuity of 120. According to the NBV, it's very easy. NBV is equal to BV of cash inflows minus BV of cash outflows. Our BV of cash inflows, it is a perpetuity cash flows. But in this case, we implement our equation, which is C divided by R. C is 120 divided by R, a discount rate, which is given 10, and then subtract our initial cost, which is 1 million. Our NBV equals 200,000 USA dollars, which is positive. In this case, we accept the project. But let us see how could we examine this project using the concept of economic value added. In the concept of economic value added, EVA, this is equal to the pure economic value that we are going to earn. This means that every year we are going to earn 120,000 USA dollars. Our initial costs, it is 10% per year. This means that 10% multiplied by its initial cost. This means that our initial cost of capital, it's 100. 100,000 minus 120, so our pure economic value, it is 20,000 USA dollars, and this is the idea of EVA and how could we use it in comparing two projects. The final technique that we are going to discuss, it's called internal rate of return. What is the internal rate of return? Internal rate of return, it is a sophisticated capital budgeting technique. We are aiming to determine the rate of return at which our NBV equals 0. And we are aiming to determine the rate of the return that the firm will earn if it's invest in the project and receive the given cash inflows. Generally, when you are trying to compensate the internal rate of return in the equation of NBV, you will find that NBV equal to 0, as you see in this equation. This equation, actually, this is a equation of NBV, but in this case, we are going to replace the discount rate by the internal rate of return. By replacing internal rate of return instead of the discount rate, we are going to receive NBV of 0, and this is the idea of internal rate of return. After we determine our internal rate of return, we are going to implement the following decision criteria. What is this decision criteria? If the internal rate of return is greater than the cost of capital, in this case, you should accept the project. If the internal rate of return is less than the cost of capital, you should reject the project. Mathematically, decision criteria is if internal rate of return is more than K, we should accept the project. If internal rate of return is less than K, we should reject the project. If internal rate of return is more than equal K, in this case we are in a technically indifferent, or this is a neutral decision. Let us give a look for this here. As you see, this figure try to determine the internal rate of return graphically. As you see, internal rate of return will be determined through the relation between discount rate and the NBV. Give a look. We started by a discount rate of 0 and we compensated in our equation. We found that the NBV is 100. Then we started to increase the discount rate from 0 to 4%. We found that the NBV is 71.04. Then we increased the discount rate to 8%. We found the NBV is 47.32. We increased it to 20. As you see, we found it is turned to be negative 1.74. This means that our internal rate of return, it's existed between a discount rate of 16 to a discount rate of 20%. We compensated in this figure. We found that the internal rate of return exactly it is at the level of 19.44%. At this level, NBV should equals to 0. The question is how we could determine this approach. Actually, this approach will be determined. How could we determine the internal rate of return? This could be determined by the interpolation discount rate method. And this is just for your information, because it will take a long period of time to calculate and to compensate, just for your understanding. This 19.44 is determined using by the interpolation method. Recently, we could adopt the internal rate of return using the mathematical algorithm implemented in Excel sheet. As you see, this is a very easiest and a quick way to determine the internal rate of return using Excel sheet. As you see here, we have year 0, and we have 1, 2, 3, 4, 5. This is a period of cash flows that we are going to receive. We are interested to determine what is the internal rate of return of this project. In this case, if you are interested to determine the internal rate of return, you must use the function internal rate of return in Excel. How it is, as you see, in cell B10, to determine its value, you are writing equals internal rate of return, and then you set all types of cash flows that you are receiving, whether these cash flows are in cash flows or whether it is out cash flows. You are taking all cash flows from B4 to B9 and then implement this function. Just you enter, then you are going to determine what is the value of your Excel sheet in a very accurate way. Then we compare it with our cost of capital. If the internal rate of return is more than cost of capital, you are going to accept the project. If it is less than the cost of capital, this internal rate of return will be rejected because it's not profitable for your firm. Sometimes, when you are using NBV and the internal rate of return, sometimes you could have a conflict. And actually, no guarantee that NBV and the internal rate of return will rank a project in the same order. No guarantee is this. So you must be careful about this when you are trying to calculate and to compare between two projects. But both of them, in most of cases, they are going to give you the same conclusion about acceptable or non-acceptable of a project. But according to a rank, maybe you have different ranks, no guarantee. In most of cases, a conflict in this between results is not unusual. But sometimes could occur, and you must be careful about both of them. But in general, it's very important to take this in your consideration when you calculating NBV and internal rate of return. But by the end of this lecture, we are stopped at slide 40. By the end of this lecture, we explaining what the concept of capital budgeting process, why this process is important. We compared between capital expenditures and operating expenditures, and then we explained a difference between independent project and mutually exclusive project. Also, we explained 5 techniques that could be used for comparing between different projects, and we explain the decision criteria that could be used for supporting this. At the end of this lecture, I wish for you all of the best, and see you inshallah for next lecture with my best wishes, Professor Tamer Shahwan.